Okay, so here's what we're looking at. In blue are a bunch of data points. Remember, that's a correlation with x and y. So these blue points each represent a point in this sample space. So for our example, the horizontal axis is the amount of alcohol as a percentage, and the vertical axis is the amount of calories. So as I move these around, and notice this is entirely dynamic, I can move these around. The average moves with it. So the average is actually determined by the average of all of these blue points. So all this data determines the average. So that average is simply the sum of the x's divided by their number, comma, the sum of the y's divided by their number. Now this other point is not fixed. I can move it around. And as I do that, you can see that I'm rotating this other point through that average. The average is, we're sure that the average is on the regression line, so we're just pivoting around the average. Now, what I would like to do is make the magnitude of these residuals as small as possible. So I'm going to turn on those residuals. Notice that that's the vertical distance from the curve, or from the line. I'm not going to call it the regression line yet because I'm pretty sure I could do a little bit better than this, but let's find out. As I move it, I can see those residuals changing. So in the top graph, they're the green vertical lines connecting the line to the point. And in the bottom graph, that's the magnitude of those residuals. And I want them to be as close to zero as possible. Well, I want this line to be as close to the majority of the data as possible. And I don't know, I'm thinking, let's see, if I bring this up, then some are going away and some are getting closer. I see more getting further away than closer. I'm going to settle on something like that. Let's see what the real linear regression line is. I got pretty close, but basically we start with the average point and then we rotate around the average point until we get the residuals as close to zero as possible.